My name is Thomas Schmidt. I'm CEO of Citizens Energy Rhein-Sieg, CEBRS. We are based in Siegburg, and we are in the Bonn-Rhein-Sieg region in Germany. So today I'd now like to talk about the value chain. This is something that helps everyone in the region, all the people and partners who are involved in the project. And that's what I would like to tell you about the project here in Siegburg today. We are standing here on the roof of the retirement home in Siegburg, and as you can clearly see behind me, there is a lot of roof area available here for a PV system. And by using this example, I can give you a great explanation of how a value chain can work. First, of course, you look for suitable roofs in the region and ask the owners or users of these buildings whether they are interested in the roof being covered with a PV system. Then, the next step is to go there and try to talk to the owner about the specific details. Once we've been to a building to have a look at the electrical installation and get a first rough overview, then we try to run a first simulation to see if such a property has potential. Whether we can use a relatively large amount of electricity in the building itself, so that only a little bit of electricity needs to be fed back into the grid. Based on all this information, we then try to carry out a profitability or feasibility calculation. Armed with this calculation, we speak to the owner and the users of the building again and try to sign a contract with them in order to then start the project together with the owner. To understand the value chain, you must understand which steps are necessary. The first step is, of course, you must mobilize a lot of people, including our CEBRS members, the owners, architects, planners, tenants, people using the building in question, and then together everyone comes up with the idea to realize the project of putting a PV system up on this roof. If you take a closer look at this property, you'll see relatively quickly how much energy can be generated on this roof, and how much energy you can perhaps use in this building, because this self-consumption is an important aspect of the value chain. This means that the energy that's generated at this location does not need to be generated somewhere far away and then be delivered to the building via power lines. So this is the first step, confirming a high level of self-consumption. The second step is, of course, to try to achieve the optimal utilization of this roof during the planning phase. So, involving the local planner, a project engineer who can plan a PV system, discussing how to implement such a system with a master electrician, and then as a third step working with your own members to finance this project. Then the project is actually almost finished. The next step is to sign a contract with the owner, because we have to make sure that we can also use the roof, and the owner needs to know what rights and obligations he has, and what happens after 20 years, should we want or have to dismantle the PV system, or if there is a power incident, for example. Once the contract is signed, we can put a tender out for the PV system. We can involve local companies, invite them to submit an offer and take part in this project. The system will be built. We invite our members to invest or contribute to the project financially, because many members may not have their own house, cannot put a PV system on their own roof, but would like to see projects in the region implemented. And of course, we have a soft spot for the region. And so in the end you can of course actually find someone who really can support projects like this. In the end we finish the project and can officially open it together with the owner and our members and generate the first electricity, so to speak. So, who have we got in this value chain? We've got the owner, we might have the tenants or the building users, the commercial users in the building who would use the electricity. We'll have the local electrician or the solar technician who built the system, and we'll get the network operator on board who will ensure that surplus electricity will be fed back into the grid later, and there will be many, many smaller companies and tradespeople who work on the project. For example, the roofer, or the specialist setting up the lightning protection. The value chain on this roof project, for example, was exactly as I've just described. We looked at the aerial photo of our town for the first time in 2011, checking which roofs would be suitable. And so, this property immediately caught our attention. It is a relatively large property. There's a main building, and 3 separate buildings that extend from this main building, and on this actual flat roof. As you can see here nicely, we've actually got monopitch roofs. These monopitch roofs have been laid out in 10 different directions. And this means that in the summer I can catch the sun from 4:30 a.m. till 9:30 p.m. So I get a whole day's worth of solar yield in the summer, not in the winter.
Tagverlauf im Sommer, im Winter nicht, wo ich den Sonnenertrag gewinnen kann.
As nice as it is on the one hand, it is of course very difficult to monitor this on the PV system, because each individual roof has to be compared individually with its target and actual values. It is also a retirement home, a very sensitive project, because you want to avoid a fire or any potential negative effects in a retirement home as much as possible, which is why we designed the PV system in such a way that almost all the technical equipment is on the roof, and there's actually very little installed in the building. We can illustrate the value chain here relatively quickly. On the one hand, I get 80% of 220,000 kilowatt hours of self-generated electricity annually. That is around 170 to 180,000 kilowatt hours annually, which the building's users can have at a relatively low price, because ultimately photovoltaic is a very cheap form of energy. The remaining electricity is fed back into the grid and can be used again immediately by the neighbors. The value chain in this project is a very special one. We had our first conversation with the owner here in 2011, and he was positive about the project, said that it was great and that we should definitely do it, but we weren't able to sign a contract back then. It took until 2015 to sign a contract with the new owner and implement this project together with him. It's a relatively large PV system that you can see behind me. This is a roughly 260 kilowatt peak system that generates 220,000 kilowatt hours per year, 80% of which is used in-house. It wasn't planned that way at the beginning, because the building consists of 4 blocks, 4 parts of the building that are all connected to one another, and each individual block had its own electricity connection. When planning a PV system like this, you need to think about how to achieve optimal self-consumption, and with 4 different meters that is difficult. You have to assign the output of each of the individual PV systems on each of the individual roofs to a single meter. We are now standing on the main building's roof. The cafeteria and kitchens are downstairs, but this is also the smallest part of the PV system, so the self-consumption would have been relatively small. So, we thought about how to get around this problem. We suggested to the owner to reduce from 4 meters down to just 1 meter. This means to redesign this meter system. This gave us the great advantage that we didn't need to split up the system between the individual meters. We were able to go down into the meter room with 1 mains, and with the relatively high level of self-consumption, this saved us a large 5-digit sum. To achieve this, we also rebuilt the low-voltage main distribution, the technical term, in the owner's basement, which was also later extended, which led to the project being profitable for everyone, so to speak.
so konnte man sozusagen gemeinsam einen Gewinn daraus erwirtschaften. Jetzt haben wir ein tolles Projekt hier realisiert.
Now we've implemented a great project here, but actually we would really like to do more, because on the other side we have houses in the immediate vicinity that do not yet have a PV system. Or homeowners who would like to put up a charging station, electricity for their electric cars, and we generate energy here, but we cannot use part of this energy, 20%, at all.
Ein Teil dieser Energie können wir gar nicht verbrauchen. Wie schön wäre es, wenn man diese Energie...
It would be great if this energy could also be made available to the neighbors, but it is not possible yet, because there is a property border between this building and theirs, and we still have the technical and legal obstacles that make this difficult. My appeal to politicians would be to remove these obstacles so that this electricity can also flow easily to the neighbors.
Gut zum Nachbarn rüberfließen kann.